Hello all. So the topic of this session today is about inversion of mechanism. So earlier we have seen about that mechanisms, what are the types of mechanisms are there, and whether it is coming under the kinematic chain or not, how can we determine the degrees of freedom. So in this way we just seen in detail in our previous session. But today we are going to see about the types of mechanism. Here it is what you call that inversion. Generally, in terms of inversion in English meaning, it means there is some reciprocal. That is what you call that inversion. So here inversion of mechanism means when we fix some different links other than conventional fixer link, if we fix some other different link or input link, we may get some kind of mechanism. So what are the kind of mechanisms are there? Suppose if we fix the different links, what kind of mechanisms has been newly created? That is what we're going to see here. So inversion mechanism is generally, let us take that is the case. Here, generally inversion is nothing but by fixing different links we will get the inversion. Okay, so let us take a case about 4-bar chain. So we know that 4-bar chain means generally we having 4 links, 4 different links are there. So inversion means if I am going to fix any one of the link in that 4-bar, what will be their types of mechanisms has been newly found. The first one, it is called beam engine, and the second one, coupling rod of locomotive, and the third one, it is a watt indicators mechanism. Beam engine is also called it as a crank and lever mechanism, and the coupling rod is also called it as a double crank mechanism, and watts indicator is also called double lever mechanism. So here some of the example for inversion of 4-bar chain. It is a beam engine. The first type it is what you call that beam engine. Why it is called beam? Generally beam is nothing but it's like a cantilever or whatever it is. Here this shape is what you call that beam. Here whenever there is a rotational motion takes place, what happens? This beam will trying to oscillate with the help of this fixer one. So here this one is a fixer but this one is moving, and because of this oscillation what happened, the piston will start do reciprocating. When the piston will start reciprocating, because of this sliding motion what happened, this link will start rotating. Okay, so this is the this is what you call that different links. When we fix the different links we will get the output like this. Okay, so here there is a rotation takes place. Because of the rotation the beam has been oscillated. Because of the oscillation the piston has been reciprocated. Because of the piston this link will start rotate with the help of this fixed beam. So this is what you call that beam engine, or also called it as a crank and lever mechanism. So when we take into the second case, that is a coupling rod of locomotive. Here we know that in our normal train, for example if you take a train engine, so we having a wheels has been interconnected. The wheels on the rails which has been interconnected with the help of this coupling rod. This is what you call coupling rod of locomotive. Okay, so here it is what you call the double crank. Generally rotational part is what you call that crank, and reciprocating part is what you called as it is a lever. Okay, connecting rod is like an oscillatory motion. Okay, so here both are AD and BC are same length, and it has traveling the same kind of rotation, and because of that it produces some rotational output in the wheels. So that is what it is called it as a coupling rod of double crank mechanism. So when we take the watt indicator mechanism means here you just take a case study about this diagram. Here when there is a wheel will start rotate, the beam will start oscillating. Because of the oscillation what happened, this beam will start rising in this left hand side, and because of the rising movement the piston will start move from the BDC to TDC. But here there is a one more link has been fixed. When there is a motion takes place in the upward direction, immediately due to this another link it has been pulled down because of the gravity. Okay, so this gravity which never let this beam to lift up, okay, and it maintains the same thing. This is what you call the double lever mechanism, which means double lever. Why it is called double lever means here we having already one lever, it produces the oscillatory motion. Here there is one more lever, it resisting the oscillatory motion. That is why it is called double lever mechanism. Okay, let us take another one. It is a single slider crank chain. Here we having a piston, and this is the piston, this is the crank, this is the connecting rod. When there is a crank make a rotation, the connecting rod will trying to push over the piston, and also this it can make a direction either in left direction or in right direction in the linear. Okay, so because of that the turning path has been induced. So this is why what do you call that single slider crank chain. When I'm going to fix the different links in the same single slider crankchain mechanism, I may get this is what you call crank is fixed, this is connecting rod fixed, this is slide is fixed. So by fixing this different kind of links, I may get this kind of output mechanism. That is what you call the pendulum pump, oscillating cylinder engine, rotary internal combustion engine or genome engine, and crank and slaughter lever mechanism, and Whitworth quick return mechanism. These all mechanisms comes out because of fixing the different links. So with this I just go on wind up, and thank you so much.